Tonight, NASA has confirmed that after 36 years in space, Voyager 1 has left the solar system as we know it. That's farther than any man-made object has gone before, into interstellar space about 11.5 billion miles away.
Right now, as you are reading this, something extraordinary is happening far beyond Earth. Something almost no one is paying attention to. A machine roughly the size of a small car is traveling through a region of space that no human has ever seen, no spacecraft had ever explored, and no scientific model could accurately tell us what we would find there. And this isn't some brand new spacecraft built with today's technology. It was created decades ago, before the internet became part of everyday life, before personal computers were common, and before many of the scientists studying its data today were even born. The spacecraft operates on only around 4 watts of power. To understand how little that is, the tiny light inside your refrigerator can use more electricity. Yet this incredibly old and underpowered machine, designed to survive for only about 5 years, is still transmitting information from the edge of the unknown. And some of that information is forcing scientists to rethink what they believed they understood about physics. Researchers aren't simply calling the results interesting or surprising anymore. They're describing them as astonishing, confusing, and in some cases, admitting that their previous assumptions were wrong. This is the story of Voyager 1. But here's what most headlines aren't telling you. The biggest mystery isn't only what Voyager 1 has discovered in the darkness beyond our solar system. It's what those discoveries could mean for life here on Earth. It's also what is happening to Voyager 1 right now in 2026 and what could happen within the next few months. A milestone already marked on the calendar that will represent something humanity has never experienced before. So stay with me, because by the time this story ends, you may never look at the night sky in quite the same way again. I'm Your Name, and this is your channel. Subscribe if you want more stories like this, because we're only getting started. Now let's go back to where it all began. September 5th, 1977. A rocket launches from Kennedy Space Center in Florida, carrying a spacecraft called Voyager 1. The mission sounds simple enough. Fly past Jupiter, continue towards Saturn, capture photographs, gather scientific measurements, and then drift farther into space until the spacecraft eventually goes silent. NASA expected the mission to last around 4 years, perhaps 5 if everything went perfectly. By 1981 or 1982, scientists imagined they would be celebrating its conclusion. Voyager 1 was supposed to be a successful journey through the outer solar system, a collection of remarkable images and scientific data, followed by silence. But that is not what happened. Voyager 1 kept going. It flew past Jupiter in March 1979, sending back close-up images that revealed a world humanity had never seen in such detail. Then, in November 1980, it reached Saturn and continued its journey, gaining speed from the gravitational pull of the planets like a cosmic slingshot. With every encounter, Voyager traveled farther, crossed more territory, and moved deeper into the unknown. By the end of the 1980s, Voyager 1 had already traveled farther from Earth than any human-made object before it. And somehow, it was still working, still transmitting, still sending its incredibly weak signal across the growing emptiness of space, still collecting information, using technology that modern engineers can barely believe is still functioning. Then came 2012. 35 years after launch, Voyager 1 reached a boundary that changed the meaning of its entire mission. It crossed the heliopause. If you've never heard that word before, understand this. It represents one of the most important boundaries in our entire cosmic neighborhood. Crossing it was like stepping outside the protective environment humanity had always considered home. Here's how it works. The sun doesn't simply give us light and warmth. It constantly releases a stream of charged particles known as the solar wind. This powerful flow moves outward in every direction, creating a gigantic protective bubble around the solar system. Inside that bubble are the planets, moons, asteroids, comets, spacecraft, and of course, every living thing that has ever existed on Earth. But eventually, far from the sun, the solar wind begins to lose its strength. It reaches a point where the pressure of interstellar space pushing inward becomes strong enough to stop it. That boundary, where the sun's influence finally meets the space between the stars, is called the heliopause. It is essentially the outer border of our solar system. Everything inside is still under the sun's influence. Everything beyond it is something entirely different. Then, in 2012, Voyager 1 crossed that boundary and emerged on the other side. It became the first human-made object to enter interstellar space. This wasn't just a symbolic achievement or some technical interpretation. It was the first physical creation of our civilization to actually travel into the space between the stars. And incredibly, it didn't stop there. Voyager kept communicating. Think about how extraordinary that really is. At this very moment, humanity has an operating scientific instrument sitting in interstellar space. It isn't circling a planet. It isn't simply traveling through the distant outer solar system, and it isn't hovering somewhere near the heliopause. It is genuinely inside the cold, dark, and ancient environment that exists between star systems. No scientist has ever physically entered that region. No telescope has ever observed it from within. Every previous understanding came from observations made from Earth and models created by scientists here. Voyager 1, however, is giving us something completely different. It is sending measurements directly from inside that mysterious environment. And what those measurements are revealing is far from what scientists expected. This is where the first major surprise appears. For decades, long before Voyager ever reached interstellar space, scientists had developed sophisticated mathematical models to predict what that environment should be like. These weren't casual guesses or rough theories. They were carefully constructed, peer-reviewed models developed and tested by some of the world's leading physicists, and most of them painted a similar picture. Interstellar space, particularly the plasma existing between stars, was expected to be relatively calm and uniform. A thin, extremely cold, and incredibly sparse environment where particles moved slowly and very little changed, almost like a gigantic cosmic waiting room separating one star system from another. But when Voyager 1 entered that supposed quiet zone, it discovered something completely different. It wasn't a peaceful waiting room, it was more like a storm. Beginning in 2017, Voyager 1's plasma wave instrument started detecting something scientists hadn't anticipated and couldn't immediately explain. It was a persistent, narrow-band emission, a faint but remarkably steady hum, moving through the interstellar plasma. According to the existing models, this kind of signal shouldn't have appeared in this particular way, and this wasn't a brief event that happened once and disappeared. It wasn't a sudden spike that researchers could blame on an instrument malfunction. The signal continued. Year after year, Voyager kept detecting it across more than 900 million miles of interstellar space. To understand the scale of that distance, consider this. Earth is about 93 million miles from the Sun. Voyager's observations of this emission extended across a region roughly 10 times farther than the distance separating our planet from our star. Scientists examining these measurements and publishing their findings in the peer-reviewed journal Nature Astronomy reached a conclusion that challenged the old picture of interstellar space. The region between the stars isn't the smooth and featureless void scientists once imagined. It is turbulent, it contains structure, and that structure exists across an enormous range of scales, from distances that can be measured in meters to regions stretching across millions of miles. In other words, interstellar space is filled with movement and complexity that remained completely hidden from us simply because humanity had never placed an instrument inside it before. Now stop and think about what that means. For generations, our understanding of everything beyond the solar system was created from the outside looking in. We stood on one planet, pointed telescopes toward the darkness, gathered observations, built mathematical models, and used those models to describe what we believed existed out there. But now, for the first time, we have an instrument actually inside that environment. And Voyager 1 is telling us that our picture was incomplete. The universe beyond our solar system is more complicated, more active, and more structured than we understood. But this is where the story stops being just another fascinating discovery about distant space and becomes something much more personal. Because what happens in interstellar space doesn't necessarily remain there. It connects directly back to Earth. The same enormous boundary separating our solar system from that turbulent environment is also part of the protective system surrounding our planet. The heliopause isn't simply a line scientists draw on a diagram, it acts as a shield. It helps reduce the amount of dangerous cosmic radiation and high-energy particles traveling through space from distant stellar explosions before they can reach the inner solar system at their full intensity. And if that protective boundary is weaker, more unstable, or more unpredictable than our existing models suggest, the consequences for life on Earth could be significant. What Voyager 1 is showing us is that the environment pressing against that shield from outside is far more turbulent, changeable, and energetic than scientists once believed. We still don't know exactly what these discoveries mean for the long-term strength and stability of our solar system's protective boundary. But the fact that scientists now have to seriously consider that question represents a major change in how we understand the environment surrounding our planet and how vulnerable our species might actually be. But the story is about to become even stranger. Before we reach what Voyager 1 discovered at the boundary itself, we need to go back to 2023, because that was the year the spacecraft came dangerously close to going silent forever. For nearly 5 months, Voyager 1 continued sending a signal toward Earth. The problem was that the information inside that signal made no sense. Instead of readable scientific data, NASA's engineers were receiving corrupted information, scrambled code, and meaningless output that even a team with decades of experience working with Voyager couldn't properly interpret. Voyager 1 itself was still alive, and its signal was still reaching Earth, but the data it was sending had become unreadable. For a mission operating since 1977, engineers had never faced anything quite like it. Eventually, they found the cause. A tiny memory chip inside Voyager's flight data system had degraded after nearly 5 decades of exposure to cosmic radiation. That small piece of 1970s hardware was corrupting the software responsible for formatting and transmitting scientific data. Under normal conditions, the solution would be simple: replace the damaged component. But Voyager was nearly 15 billion miles away. No technician could reach it, so engineers had only radio commands, with each message taking about 22 hours to travel one way. Every test therefore required roughly 44 hours before the team could see the result. They had to study the corrupted data, develop a theory, send instructions, wait, analyze the response, and try again. This process continued for months, with every command carrying the risk of permanently ending the mission. Eventually, the JPL team discovered that the damaged software couldn't be repaired where it was, but it could be moved. They divided the affected code into smaller sections, relocated them into different parts of Voyager's memory, tested each piece, and carefully reassembled the system. It was essentially brain surgery, performed remotely on a nearly 50-year-old spacecraft from 15 billion miles away. And somehow, it worked. By mid-2024, Voyager 1 was once again sending clean scientific data to Earth, including more measurements of the strange plasma activity and turbulent structure of interstellar space. The spacecraft, expected to die decades ago, had survived what could have been its final silence. And once again, Voyager 1 came back online with more secrets to reveal. Voyager 1 still had more to tell us, but nothing had prepared scientists for what it encountered when it crossed the heliopause in 2012. For decades, scientists expected the transition to be gradual. The solar wind would weaken, the interstellar environment would slowly take over, and the two regions would blend together almost like a river meeting the ocean. But Voyager found something far more extreme. At the heliopause, particles were moving at incredible speeds and producing temperatures approaching 30,000 degrees Celsius. This wasn't happening near a star, but at the outer edge of our own solar system. Some researchers have described the region as a kind of wall of fire, a dense zone of highly energetic charged particles surrounding our cosmic home. Then came the magnetic surprise. Scientists expected the Sun's magnetic field and the galaxy's magnetic field to remain separated. Instead, Voyager revealed evidence that they interact through a process called magnetic reconnection, allowing energy to move between the two environments. That means our solar system isn't as isolated from interstellar space as scientists once believed. The heliosphere is far more dynamic and interconnected than previous models suggested, and that could change how we understand the protection it provides Earth. Now we reach 2026, and Voyager's story may be entering its final chapter. The spacecraft is running out of power. Its instruments are being shut down one by one, not because they have necessarily failed, but because there simply isn't enough electricity to keep everything operating. Voyager's 3 radioisotope generators produced around 470 watts when it launched. After nearly 5 decades, that output has fallen dramatically and continues dropping every year. By the early 2030s, Voyager is expected to become permanently silent. But NASA isn't giving up yet. Engineers are reportedly testing an experimental procedure designed to redistribute power more efficiently. If it works, Voyager 1 could potentially regain enough power to operate an instrument that was recently switched off. And then comes another historic milestone. On November 18th, 2026, Voyager 1 is expected to reach 1 light day from Earth. At that distance, a radio signal traveling at light speed would need an entire 24 hours to reach it. No functioning human-made object has ever been that far away. Eventually, Voyager's final signal will arrive, but the spacecraft itself won't stop. It will continue drifting through interstellar space at roughly 38,000 miles per hour, long after its instruments fall silent. And attached to it is the Voyager Golden Record, a message containing greetings in 55 languages, sounds from Earth, music, scientific information, and a map showing where our planet can be found. Carl Sagan called it a message in a bottle thrown into the cosmic ocean, and that is exactly what it is. Long after humanity's cities and civilizations are gone, Voyager will still carry evidence that we existed, that we were curious, and that we once looked toward the stars. But Voyager's most important discovery may still be happening right now. Since 2017, it has been detecting a persistent plasma signal that scientists believe provides humanity's first continuous, real-time measurement of interstellar plasma density. Before Voyager, researchers could only collect occasional measurements when major solar events disturbed the heliopause. Voyager is giving us something far more valuable, a continuing picture of interstellar space as it moves through it. And that picture shows that the space between stars isn't empty or featureless. It contains turbulence, structure, charged particles, and magnetic fields interacting with the outer edge of our solar system. The mystery is that scientists still aren't completely sure what is producing the signal. It could be natural plasma oscillations, or it could be a phenomenon called quasi-thermal noise, an explanation that might force scientists to rethink parts of our understanding of interstellar space. The problem is that Voyager 1 is slowly running out of power. More instruments are being shut down every year, and no new mission currently exists that could replace it. Even if a new spacecraft were launched today, reaching the heliopause could take decades. So when Voyager 1 finally goes silent, the question it raised may remain unanswered for a very long time. Voyager 1 itself, however, will continue moving through interstellar darkness at roughly 38,000 miles per hour, carrying the golden record with it, continuing a journey that began in September 1977, when engineers launched it, expecting only about 5 years of life. And that's perhaps the most remarkable part of the entire story. In 2026, the only functioning scientific instrument humanity has ever placed in interstellar space is nearly half a century old. It was built before personal computers became common and operates on less electricity than a household light. Yet this ancient machine is still sending us information that is changing our understanding of the universe and our place within it. We've built larger spacecraft, we've built more powerful machines, but nothing else humanity has ever created has traveled this far and continued talking back to us. We've built machines that cost far more and use technology far more advanced than Voyager 1. Yet none of them have revealed what Voyager is revealing today, because Voyager had something those machines didn't. It simply kept going. Some questions about the universe cannot be answered from Earth. Not with telescopes, satellites, or missions to nearby planets. Some answers can only come from a machine that actually crosses the heliopause and enters the space between the stars. Humanity has only one such machine. It's nearly 50 years old, slowly losing power and operating on just a few watts. But as long as that signal is still reaching us, we have to listen. Because when Voyager finally goes silent, some of the questions it has helped us answer may become silent with it for an entire generation. Right now, that faint signal is still traveling across billions of miles of space, carrying information about a universe far stranger, more turbulent, and more connected than we ever imagined. One machine, a few watts of power, and one final chance to listen. The only question is, are we paying attention? If stories like this are why you watch, subscribe, and turn on notifications, because next time we're going even deeper into the places where science is still searching for answers. And tell me in the comments, what surprised you most about Voyager 1? Share this video with someone who needs to hear this story, because a journey this extraordinary deserves more than silence. Thanks for watching.